All right, so we're officially live on the YouTube. So what's up, everybody? Yeah, welcome to workshop number 3 of the Beginner Cadence Bootcamp, May 2022 edition. And in today's workshop, we're going to be going over resources and references, which is probably the most difficult topic we're going to cover. So I wouldn't be surprised if we lose a lot of people today, but we're going to do our best to teach this topic. So yeah, let's just go for it. So we're starting with chapter 3 in the next workshop. We're gonna hopefully cover day 1, 2, and 3. We might not get to day 3, but I'm hoping we do. And yeah, so sort of looking back a little bit, I want to go back a little bit to chapter 1, day 2, I believe it is. Yeah, so in chapter 1, day 2, we had mentioned resource-oriented programming. And this was something that, initially I was saying, don't worry about it. We're going to come back to this later. Well, lo and behold, we're here now. And, it's a pretty big topic. And the reason for that is because resources are, the core of Cadence. It's what makes Cadence, Cadence. When we think about other smart contract languages like, Solidity, on Ethereum, it's very different because Solidity doesn't deal with resources. It has no idea what they are. But it's special to Cadence, and it makes Cadence really fun, but also a little challenging at first. So, with that being said, let's just dive into chapter 3. So we're starting with chapter 3, day 1, resources. And, you can read through here. I'm going to start with this. I'm not going to go through this right now. I'm just going to jump right into the playground where I'm going to start talking about, how to make resources and stuff like that. So in the previous workshop, we were talking about structs, right? And we mentioned that structs were containers of data. It's almost like, if you have a profile struct, you can put a name and an ID inside of it. And, we also mentioned you can put functions inside of structs. So you can have like public function, public function, change name. And, you can change the name by saying, self.name equals some random name, right? So, we mentioned that, it's a container. And the cool thing is that, that's this same concept sort of applies to resources, and that resources are also containers of data. Let's actually go ahead and make a resource right now. So let's say public resource profile, and we're going to say a similar thing. So why don't we just go ahead and copy everything? So you'll notice the way that we, and it's complaining because we have another, sort of thing called profile here. So let's get rid of the struct now. Now you'll notice that all I did was pretty much just change this keyword from struct to resource. And this actually significantly changes what this is, even though it looks the same. And the reason for that is because of all the different behaviors that are associated with resources that are not associated with structs. So with a struct, let me just go back a second. Let's get rid of this for a bit and go back to, just a struct. What a struct does is it allows us to, make them whenever we want, and it allows us to do that outside of the contract. So if I go ahead and, deploy this, right, it's deployed to this account, I can go to the script, and I set this up beforehand just so that we could save some time. So in this script, I have a function main, I return a profile struct, and, I create the profile struct right here, pass in a name and an ID, and I return it. And this, this is pretty simple. It just allows me to create my own profile. I can do it whenever I want. It's public, and anyone can do it, right? And also notice that, like, nothing, it acts like a normal data type, right? It's almost like returning a string here. Or whatever other data type there is. But resources are very different. And the reason for that, which I believe I list right here under this resources versus struct section, is one, resources cannot be copied. They cannot be lost or overwritten. They cannot be created whenever you want. You must be extremely explicit about how you handle a resource. And they're much harder to deal with. So a lot of that's sort of vague, but let's explain why. So if I change this to a resource, it's still a container of data, right? It still has a name, it still has an ID, but you'll notice that we can no longer do this. And actually, I believe if I refresh the page, it's going to give us a problem here. Oh, it's because I forgot to redeploy. There we go. So let's redeploy. Boom, we redeployed. And now if we go back to our script, hopefully it should give us some errors. Yep, and it does. So there's a lot of different things going on. What's the problem here? Well, one, it says missing resource annotation. Now, the reason for this is because the one difference between a struct and a resource is that when you're referencing a type of a resource, you have to put an @ symbol in front of it. So that's one difference right there. If you see in code a little @ symbol, that means it's a resource. So that's one thing. Another thing is it's saying it cannot create the resource it's expecting create. So one thing that we also have to mention is that when you actually create a resource, you have to put the create word ahead of it. You can't just make it out of thin air. You have to put this little create keyword. And lastly, because they're resources, we have to move them somewhere, which is also really confusing. But with a struct, when we create a struct, we just create it and return it. With a resource, we have to create it and then move it into the return. So this is called a move operator. Let's just mark that down. So this is called a move operator. So we have to take the resource and move it into the return so we can actually return it. Now, there's one last error here that we can't solve, and this is saying we cannot create a resource type outside of the contract. So the last big difference between a resource and a struct is that this is actually wrong. We can never create a resource outside the contract. So all of this is completely invalid. So what that means is, the only area we can actually create a resource is inside the contract it's defined in, which means we have to make a public function. If we want to create this resource somewhere else, we have to make a public function called create resource, or let's just say, what is it, create profile? Let's say create profile, right? And we're going to return, actually, I'm going to ask all of you in a second here what's wrong with this, but let's just keep going for now. And we're going to return a profile. And we're going to pass in some of the names, right? Because it needs a name and an ID. Let's pass in name, name and ID, and we're going to declare that right here. So in the parameters here. So with this function, based on what I just said, there are 3 things wrong. Let me try to move this to the side. There are 3 things wrong with this. Can anyone tell me what are the 3 things that are wrong with this function? Really quick.
The @ the create, and the move operator.
Exactly. Who said that? Perfect. Yeah, that's awesome. Yeah.
Turbo.
Great job, Turbo. So you put the @ symbol here. Exactly, yeah. So one problem is we forgot to put. God, I hate this. I hate this. Oh, wait, let me try and zoom out for a sec. So I hope you can still see it, but we forgot to put this @ symbol here, right? So this profile type is a resource. So now we have to put an @ in front of it. Okay. The second one is I can zoom back in now. Is we forgot to actually create it, right? We can't just create a resource out of thin air. We have to put create, okay? And the last one is the mover operator. We have to move it into the return value, just like that, and then it'll actually get returned. So now we can redeploy the contract, like so. Boom, it's deployed. And then we can go back to our script, and we can do a lot of this stuff now. So what we can do is, if we still want to return our profile resource, we can say let new profile. And let's say we're gonna it says equals hello world dot create profile, and we have to pass in a name and an ID. So I don't know, let's pass in a name string and an ID, which is a UN64, and we're gonna pass that through, and then just return the new profile. So can someone other than Turbo, because Turbo you already answered, can someone tell me what is wrong with this syntax? It's kind of similar, but can anyone tell me what's wrong with this? Move, exactly, Raven. So one place we have to move it. Yeah, exactly. Good job, guys. So we can't say equals, right? This is not right. With resources, we can't just, say equals. It can't just get put into this variable. We have to specifically move it into the resource. And then where else do we need to move? Exactly. So then we have to return it in just like that. Perfect. Great job. So now let's give it a name. Let's say Q2thec, and the ID is going to be 1. So if we execute this, boom, there's the resource. It has a name of Q2thec and an ID of 1 right here. Boom. So great job, guys. So those are some of the differences between resources and structs. With resources, we have to move, needs the @ symbol, and also you can't create them outside the contract. You can only create them inside the contract, like we did here. So yay, that's amazing. So let's see if there's anything else that I want to talk about from this day. I believe that's everything from this day. Okay, cool. Now, okay, so let's talk about one other thing. So let's say that we want to let's do something like this. Okay, so we want to return the name here. So we want to, and this is kind of stupid. Like I don't know why you would really have this example, but let's say we're going to pass in a name and an ID here, right? We're going to create a new profile, and then we want to return new profile dot name. Okay. Now there's a problem here, and we haven't talked about this yet, but this says loss of resource. So why? For some reason, it's giving us this error 15 times. No, I don't even know why. But anyway, there's a problem here. We're creating the profile, we're putting it into this variable, and then we're returning the name, but we're losing the resource. And let's go back to what I said in here. Is one of the differences between resources and structs is they cannot be lost. So this number 2 right here, they cannot be lost. Now, what does that mean? Well, it means that if we create a resource, it can't just sit there. We can't just leave it. In order to actually make sure that we handle it correctly, we have to destroy it. So what that means is, in this case, we would have to store let profile name equal the profile name, destroy the resource, destroy new profile, and then return profile name. Okay. Now, what destroy does is it takes the resource and boom, blows it up, so it no longer exists. So the resource is now totally gone, doesn't exist anymore, but we're fine because we stored the name in this variable before we destroyed it. So if we type in, let's type in, who else answered? Raven. The ID is 10. We execute. Let's clear this first. Wait, okay. We execute. It's going to return, Playground's giving us problems, of course, but, if it should return Raven. Hopefully you get the point. But let's just see. Hopefully, please. Maybe if I click save. Come on, Playground. Raven and 2. Yay, Raven. Okay, so perfect. It worked. So does this make sense to everybody? That we can't ever leave a resource dangling, right? We can't leave it out in the open. We have to either return it somewhere or we have to destroy it. Or the third option is to store it somewhere, but we'll get to that later. So how's everyone doing so far? Just with basic, and I haven't even talked about like why we would use resources yet, but just let me know if you understand like how to deal with them like at first, Like does this make sense so far?
Is that like cleaning up after yourself?
Exactly, yeah. So with resources, you have to, clean up after yourself. You can't just leave them there. Totally right. So click that thumbs up or thumbs down if you understand that, and if not, so QTech says if a resource is an NFT, do you really destroy it? So QTech, that's a fantastic question. And we're gonna actually, so we're actually gonna talk about next. That's a great segue into, well, what is an NFT on Flow? So in Ethereum or in Solidity code, this is sort of context for why Flow is made in the first place. On Ethereum, your NFT is not an actual like object. It's literally just a number in a contract. So Bored Apes, any other NFT on Ethereum is literally just a number in a contract. That's it. However, on Flow, your NFTs are resources. They're little objects that get passed around between users. And so when you like destroy an NFT, you destroy the resource. And then it's gone forever. It can never be recovered. And we're gonna go over like that doesn't really happen. Like usually you just transfer it to someone else or you give to somebody else, but you can fully, if you wanted to right now, you could destroy all your NFTs and it would be gone forever. Yep. So you have the power, you can run a transaction with any of the NFTs you own to completely destroy it. And for the record, like this is sort of why after the Dapper Labs team made CryptoKitties, they made Flow. And the largest reason for that was because of this resource-oriented program we talked about, where they wanted NFTs to truly be an object and not just a number in the contract, so that you had true ownership over your NFTs. Good question. All right. So this, I believe, covers this day. And yeah. And one other thing I will talk about that I didn't really mention is So one other thing I didn't mention is this one here. They cannot be copied. So what do I mean by they cannot be copied? Well, let's go back to our script again. So you'll see that we create a profile here, right? And let's say we don't return anything. This is just for testing purposes. Let's say we want to say, move profile here. Okay. And we move the profile to this variable. And then let's say we destroy it. Just to get rid of the errors. So what's happening here is we create a resource and then we move it into new profile, right? So right now the resource exists here. Then we take this resource, right here, and move it into move profile here. Now, at this point, right, like right here, so I'm talking about right here at this line of, like, right at this area, nothing exists in new profile anymore. It's completely empty. So that goes to show you it can't be copied, right? You can't move it into here and then copy it into here. When you move the resource using this move operator into this variable, this is completely empty now. So you can't copy them either. That's another thing to sort of be aware of. All right.
And there's nothing left to destroy in there.
Exactly. So you don't even have to destroy anything in here because it's already gone. Which is why, the only thing we had to solve for was we had to destroy move profile here because the resource now exists in this location. Yep, exactly, Ricardo. So new profile right here equals nil. I'm pretty sure we can even like assert that. So new profile. Let's check. Oh, well, okay, so it doesn't even let us do this because it's saying that it's like completely, it's like not even existent. It says use of moved resource used here after being moved. So I don't even, like, it just, nothing exists there anymore. It's just completely, like, destroyed. Yeah, worse than nil. Yeah. So for projects where NFTs are burned, what they use destroy? Yep. So when an NFT is burned, what they're really doing is they're using this destroy keyword. Yep, exactly. Awesome. So that covers Chapter 3, Day 1, and we're going to move into Chapter 3, Day 2, where we talk about actually storing resources somewhere and not just, returning them or destroying them. So let's get into this a little bit. So for this example, why don't we actually change this to an NFT and start getting familiar with how NFTs actually work? So on Flow, the way that NFTs are usually defined is they all have to have an ID. So let's put that first. And we're also going to give it a name. And we'll just leave these two for now. But it's important to know that every NFT has an ID. And for the record, the way that we distinguish between non-fungible tokens and fungible tokens is this ID here, because if two NFTs had the same ID, they would be fungible, right? Because they'd be interchangeable. So this is really what's making the NFT an actual non-fungible token, since it's not interchangeable if they're all unique. Okay, and so let's just go ahead and change this to create NFT instead of create profile, NFT, and boom, we're fine. All right, so instead of actually, returning this, like creating NFTs in the script, let's go ahead and store them inside the contract. So let's make a public var storage, I don't know, and let's just make this an array of NFTs, just like that. Okay, and so in our init, we're going to say self.storage equals an empty array. Now, one thing you have to note is that the way that we declare, like an array of resources is you would think you put the thing here because it's an array of, resources. Just like if it's an array of strings, you do array of strings like that. But with an array of resources, you actually put the @ symbol outside of it, not inside. So that's a little tricky thing, just to note. And then, one other thing is that when you actually go to initialize this array, you don't initialize it with equals. You have to put the move operator. So anytime you're dealing with a type that has resources or has this @ symbol, you always use the move operator like that. Cool. Yeah, and so what we're going to do is we're going to hopefully store our NFTs inside this array. Cool. So let's go ahead and make a function to actually do that right here. So actually, why don't we just make it up here so that we can see it closely? So public function, deposit. We're going to take an NFT, which has an NFT type. We're not going to return anything. And we have to store it inside of this this variable here. So let's go ahead and let's walk through, because I want to make sure that you guys can see where this is in the, what's it called? In the chapter as well. So we're talking about this part right here where we're adding to an array. And look what we do. We do this right here, append, the append function. So this is just like it is for strings or ints or whatever it is. It's actually really simple, where we just say self.storage.append, and we have to, the only difference is that we can't just put append NFT like that. We have to move it like that. So I know I keep saying this over and over and over again. You're probably getting sick of me saying it, but whenever we have a resource, we have to move it. We cannot just, append it like that, like we would a string. All right, cool. So let's, yep. All right, awesome. Here, echo. All right, cool. Sweet. So then let's go ahead and make one more function called public function withdraw. So we're gonna make a function to actually take an NFT out. And this is talking about the removing from an array right here. All right, cool. So let's go ahead and say we want to withdraw from a certain index. So index int, and we're returning an NFT. And we're gonna say return. Remember, we're gonna move it. Self.storage.remove at index. Awesome. Just like we did here. Sweet. So how's everyone doing on these two? Do we understand this? That in order to deposit, we have to append the NFT with this move operator, and to withdraw it, we do self.storage.remove and then at. And just to remind all of you, what the index means is that's the spot that it's at. So for example, if we have an array of, let's just say NFT1, NFT2, NFT3, NFT4, then this one is at index 0, this one's at index 1, index 2, and index 3. Okay, so that's what this index is right here. Alrighty, let's deploy this contract, and hopefully this should work. Boom, we deployed it. And because we're going to be, changing the storage now, right? We don't want to be working in the script because it doesn't make any sense. We want to be working in a transaction because we're going to be actually storing things. And look at that. The playground's being buggy again, but it should be fine. Okay, let's go to our Hello World example. And again, for these until chapter 4, we're not going to talk about prepare. So let's just keep everything in the execute function. And in here, we're going to actually deposit an NFT. So in order to be able to deposit it, we have to first create it, right? So let's go ahead and use the create function. So let new profile be hello world dot create NFT. So index starts with 0, Raven. So this is yep. So it's 0 base. So I guess it maybe be more helpful if I started this with like the actual indexes instead. Sorry, it's probably confusing. But yeah, this is index 0, 1, 2, and 3. Cool. So let's go ahead and we need a name and an ID to pass in. So let's just make these arguments. All right. So it'll create the resource, move it into here, and then where do we want to move this? Well, we want to move it into hello world.deposit, and then the NFT. So we have to move our new. Oh, it's a new profile. This should be new NFT. Then we're going to move our new NFT into here. And then log, we deposited our NFT. All right. Is that right for everybody? I'll put a thumbs up in a second. But our name is going to be, let's put turtle. And our ID is going to be 1,000. Doesn't matter which account we pick. We're not going to talk about it until later. Send. Ugh. All right, well, once again, Playground's not being nice. Try it again, just try it. Oh my god, nice, thank god. Okay, so it says, so it did it, it deposited the NFT, and now what should happen is it should exist in here. So right now the NFT is in here, okay? So how do we actually check that? Well, we'd have to write a function to check it, but let's just trust me for now that it's in here, right? Just let's not worry about it till later. So just for now, just trust me that it's in here, okay? Awesome. So now let's go ahead and withdraw it. So let's go ahead and make a new transaction. We're going to call this withdraw. And while we're at it, let's just make this called deposit. Okay. Let's copy this code, put it into withdraw. And so now instead of creating and depositing, we're just going to withdraw directly. So let my NFT be hello world dot for this dot withdraw. index 0, right? Because nothing's going to exist at 1, so just put 0. And then we're going to log mynft.name and then destroy mynft. Say we withdrew mynft, right? And so we're going to get rid of these two and put index. Well, actually, let's just make this index this and just say index. And I think this actually has to be an int, not a uint. All right, cool. So if we put 0 here, what should happen is it should go into this storage, right? This storage right here. And it's going to withdraw it. So self.storage.remove from this storage at the index, right? And so we know that because we just deposited something, it exists at index 0. So let's try it and see what happens. Yay, it worked. So it says Raven, and we withdrew our NFT. Now, does anyone have any guesses, right? We just ran this transaction that withdrew and destroyed it. So what's going to happen if we try and run this again? Is it going to work?
No.
No, it's not going to work. And the reason it's not going to work is because it's gone now, right? It doesn't exist. Let's see what happens. Boom. Array index out of bounds. We tried 0, but the size is 0. So it's telling us, hey, you're trying to get the 0th element, but nothing exists here, right? Because right now, it looks like this. So doesn't work. Sorry, not going to happen. Yeah, so that is arrays, okay? So that covers this whole resources in arrays section. Next one, sort of self-explanatory, resources and dictionaries. It's actually more complicated, believe it or not. So it's actually quite a lot more complicated. So let's talk about resources and dictionaries. And most often, I think the most common data type you'll see is actually resources and dictionaries. It's extremely common and very useful. So let's go ahead and change our example a little bit to be a resource dictionary. So you'll notice now that I changed it to, we're mapping a string. Actually, let's go ahead and map the ID. So we're going to map the NFT's ID, which is a uint64, and we're going to map that to the NFT resource itself. So let's say it's going to map 0 to NFT with ID 0 and a name of Jacob, or could be whatever name. So let's change this a little bit. Let's go ahead and change this down here. It's no longer brackets. It's now curly braces. All right, square brackets. Now it's curly braces. And these are no longer going to work anymore because we're dealing with dictionaries. So we just got rid of those two. And yeah, let's talk about depositing now. So, let me just take a quick break and thumbs up. How's everybody doing? Don't be afraid to thumbs down. If you thumbs down, that's totally fine. And we'll take a quick pause and help you out. I want to make sure everyone's okay.
Where's the thumbs action?
It's in the text channel. Raven says overwhelmed by your speed. Oh no. Raven, does that mean not good? You want me to go over something, Raven, or? Oh, Spitfire says it is very quick, just in general. Oh, do you guys want me to slow down a little bit, or is it okay? Is it bad or good? Slow down. Okay, I'll slow down. I'll slow down a little bit, because I know these are recorded, and I know we only have so much time, but I will try and slow down a little bit. Yeah, exactly. Okay. So even though we were going fast, is everyone okay with, is everyone okay with the depositing and withdrawing with arrays? And if not, I guess worst case, there, it is being recorded, so. Okay, cool. Yeah, I'll try and slow down a little bit on the dictionary one because this also is going to be more complicated. All right, so we're now going to talk about how to deposit resources into dictionaries, all right? So just like we did with arrays, let's make a public function deposit, all right? We're going to take an NFT, so it's pretty similar, actually. And we need to somehow deposit this NFT into this dictionary, all right? So let's go ahead and do that. Now with arrays, we just appended it, right? But with dictionaries, we can't do that. With dictionaries, we have to do a little, special thing. Now there's two ways to do this. So let me say that right now. There's two different ways to deposit to a dictionary, and I'll tell you which one's better and which one's worse. So the first way to do it is to say self.storage at a certain key. So what is the key that we're going to put here? I mentioned this before. Remember, we're mapping at the ID to the NFT itself. So what should I put in these brackets? Close, Ricardo. So it can't be the same number because then it would always deposit at that spot. ID, exactly. But so we can't put ID because ID doesn't exist. So how do we get the ID of the NFT? No, not the address, NGI, because we want to put a UN64 here. UID, we could, but I think you guys are overthinking it a little bit. So we want to map the NFT's ID to the NFT itself. So how do we get the NFT's ID? Remember, it's right here. So if we have the NFT right here, how do we get it?
NFT.id.
Exactly. Yeah. Good job. It's NFT.id. Yep. Just like that. So yep, that'll get the NFT's ID. That'll be the key, and now we have to give it a value. So because we're putting a resource here, right? We have to move a resource into this position, and we can say NFT. Now there's a problem with this. And this is where stuff gets confusing. So when we're talking about dictionaries, we cannot simply move a resource into a dictionary. The reason for that is because what happens right now is, remember, let's go back a chapter to day 1, and I wrote, resources cannot be lost or overwritten. So this is really important, this little parenthesis here, or overwritten. Now, the reason I'm mentioning that is because what's happening right now? Well, let's say, now this theoretically should never happen, right? Because each NFT's ID should always be unique. But Cadence doesn't trust us, right? It doesn't know that it's always going to be unique. So Cadence is telling us, wait a minute, there's a problem because there's a chance that a resource already exists in this location. And if it does, what you're going to do is you're going to take our resource and you're going to overwrite it, and that's not okay. Because, what if we accidentally overwrote $1 billion Bored Ape NFT, right? So that's not okay. So in order to fix this, we have two options. We can either put this little symbol here. Now, what this symbol does, and I promise you, this is the most weird syntax you'll ever see in Cadence. It's a force move operator. So it's a move with an exclamation mark. What this says is, if something already exists at this location, panic and abort the whole program. So don't do anything. Just throw an error and don't do anything, and everything will get reverted back to the original state. But if something doesn't exist here, then you can take a resource and put it at this location. All right. So this is the best way to do it, in my opinion, because it's really simple. But I'll show you another way to do this that will help you solve for duplicates if you want. But I'm not gonna warn you. It's weird. So let's say we didn't do that. Let's say we didn't put that operator. Let's handle the case where we actually want to see if there's a duplicate. So what you do is you use something called the double move operator. So you say let old NFT, and you double move out and then destroy old NFT. All right, this is very weird. But what happens right now is it takes self.storage at nft.id, moves the old resource into this one, moves the new one into here, and then destroys the old NFT here. Now, one cool thing about this is that even if this is empty, it's still going to work. Like, it'll just move an empty thing into here and then destroy an empty thing. But what this allows you to do is that, let's say for some reason you wanted to know if there was, something there, then you would move the old one into here, and then you could say, like, instead of destroying it, you could just, like, I'll just say, like, instead of destroying, we could do something else with it. Right? So I'm not going to go over, like, what you could do with it, but this just helps you, say that, okay, we could do something with it if we wanted to. But I'm going to go back, and I'm going to do the way that I like better, and just do it with this way. And using this case, this never allows us to overwrite it anyway. So it's easier and more simple, and it's nice. So yeah, that's how you deposit an NFT to the dictionary. All good? Could double move lose your ape? Yes. So let's go back a little bit. So if we did this using this code, what would happen is it would take, it could be any NFT, but I guess we're using Bored Apes. It would take your Bored Ape, it would move it into here, and then it would destroy it right here. So totally. But what I'm saying is that like if you didn't want to do that, like you could do something else with it. Like I don't know, maybe we wanted to return it. Right? Let's say we wanted to return it. Right? So you could do that as well. I don't know why it's saying that. Oh, okay. Well, okay, I'm not going to go into that, but yeah, so like let's say we wanted to like return it to the caller, right? So you could do other stuff with it, but I was just putting destroy here so that it would get rid of that error. But yes, you're right. Using this case, it would definitely destroy it too. But you see what I mean, right? Like you could do anything you wanted with it here. You could deposit it, you could return it back to the caller, all this stuff. But let's just go back to this example. All right. That's how we deposit. Cool. And then let's go back to removing. So that covers adding to a dictionary. We talked about the easy but strict way, which is the force move. And then we also talked about the complicated but handled duplicates way, which is the double move. And now we're going to go into removing from a dictionary, just like this. All right? Cool. So to remove, let's say public function withdraw. NFT? No. Index. We're going to say return. Right? We're going to move the resource into the return value. Self.storage. Dot. Remove. And it's going to ask for a key. So actually, this isn't an index anymore because we're dealing with dictionaries. It's a key. So it's saying we're going to give it a key, which is, one of these keys. And it's going to give us back the NFT that the key maps to, right? So, if we deposit an NFT with ID 0, ID 10, right? Those are the IDs we're going to pass into the key. And now there's a problem. And this is, one little, quirk about Cadence again, and why we talked about optionals in the last chapter. So the problem with this, the error messages suck. Oh, no, here it is. Okay, so this is the correct error message. So it says mismatch types, expected hello world.nft, got hello world.nft question mark. So can anyone tell me, thinking back to the last chapter, how can we convert this from an optional to a non-optional? Anyone remember? Nice. 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 Good job, guys. So we could put this here. Now, remember, can anyone explain to me why is this returning an optional? Dictionary. Yep. So whenever we're reading or removing a value from a dictionary, it could be nil. Exactly. So, for example, let's say the dictionary looked like this. It looked like 0 maps to NFT 0, 1 maps to NFT 1, right? So let's say the dictionary looks like this right now. So what would happen if we passed in a key that equals 2? This will return nil, right? So that's why it doesn't let us. So, yep, that's exactly why. Good job, everybody. And then we can put this here. Now, one thing I will mention is that, even though I taught you guys to put this here, I would actually, I think it's a great time to mention like the panic keyword. So right now, if we run this program, actually, I'll just show it to you. Why not? Well, let's deploy this. All right, perfect. Let's go to our deposit. And it should be the same, right? Because the way it's written is the same. So let's type in Raven, ID 100. Send it. We deposited. Perfect. Now let's go and withdraw. The only difference is it's not an index anymore. It's a key, and it's a UN64. And this should be key, right? So let's go ahead and type in a key of 100 because we know something exists there. And it says Raven, we withdraw NFT. Perfect, right? So let's go ahead and try 100 again. it's going to say unexpectedly found nil while forcing an optional value. Now, for those of you that have run into this error before, you know this is being printed because of this right here, this little exclamation mark. But there's actually a better way to do this, and if you're ever working on like a team or in a production environment, you always want to do panic instead. And the reason for that is because this right here is the same exact thing as putting this, but the panic allows you to put a message. You can say error, something doesn't exist here. So if we deploy this now, I think it's being buggy. That's not supposed to happen. Yeah, this is Playground being weird. I'm almost positive this is fine. There's a chance I have to do that. Hold on, let me just try. Okay, I mean, for the record, for all of you watching this is totally fine, but I think it's the Playground, so let me try something else really quick. Yeah, I knew it. Okay, it's the Playground being weird. So I'm doing a short trick because I've run into this problem before, where for some reason it doesn't like when you panic and return on the same line. So I just separate into two lines, but you guys can tell the difference now, right? Like it's the same exact thing, just with 2 steps. So let's just deploy this. And of course, I'm telling you, part of being a cadence dev for the past 2 years has just taught me to read Playground errors and know how to fix them. Which is kind of sad, but it is what it is. All right, please. All right, well, okay, this sucks. But anyway, the point that I'm trying to show you is that instead of printing, unexpectedly found nil, it would print this instead. So it would print error, something exists here. So I wish I could show you guys, but it's not being helpful. I'll try one more time. Oh, okay, it worked. Oh my god, nice. All right, let's try this again, please. Yay, okay, boom, yes, okay, fine. So you'll see now it prints error, something doesn't exist here, right? So it's much more helpful to people reading your application and reading from your code to know what's going wrong instead of just reading some basic error message. So a memory leak, I saw your meme, so true, so true. It's so annoying. They're trying though. I know the float team's trying. The Raven said, when Emerald VS Code plugin? Not soon enough, but trying. For sure. Definitely trying. All right, so that covers this chapter. So how's everyone feeling? Removing from arrays and dictionaries. I'll put one more thumbs up. And again, do not be afraid to put a thumbs down. We're all here to help. That's the point of these workshops, is to help you in your... All right, looks like we got a bunch of thumbs up. Cool. And for the record, because I'm such an amazing teacher, we're actually creating, like without you knowing it, we're creating our own NFT contract. So in the next 2 weeks, you'll have your own NFT contract, which would be pretty sick. And this is understanding this and these two are part of that. So also, can we patch cadence detection for normal Windows? I know it's so annoying, Raven. You can see I'm on a Windows right now, but I use Linux terminal. So yeah, I'm using Ubuntu because the VS Code doesn't work on Windows, only Linux. So annoying. All right, so we have like 13 minutes left. I really wanted to get to chapter to day 3. I'm gonna ask all of you, should we go on or should we stop? I think references, you'll see. Look how short it is. It's really short. So I think I want to do this. Is that all right? Can I get a few yeses or nos in the chat? Let's go. All right, nice. Loving the enthusiasm. Perfect. All right, let's go for it. All right, so let's do it. We have like 12 minutes to do it. It's not that hard. So look at the enthusiasm from the academy right now. All right, nice. Loving it. Also, I hope the speed was better. I tried to go slower there. Can you speed up a little? Okay, yeah. Oh, okay. Okay. Oh. And now I'm getting mixed responses. Oh no. I'm trying. All right. All right, cool. Let's go for it. All right, so um next part of this chapter, references. So before we even get into references, let's ask ourselves why references, right? Why do we even need to do references? Well, the problem right now is what if we wanted to read information about our NFT, right? So let's say snowmobiles, right? He has an NFT. It's his own Flunks, right? It's a Flunks NFT. He puts it in the contract, all right? Now, I, as a user, I want to read information about his Flunks. Right now, how would I read information about his flunk in the contract? What are the steps I would have to do? Anyone know? Assuming that like withdrawing it's fine. Like let's just assume I'm allowed to withdraw his NFT, which is not the case in real life, but let's just assume it's fine. Yep, exactly, Ricardo. So right now, without references, right now I would have to withdraw his NFT. I would have to read the name, and then I would have to deposit it back. Right? So that's really bad. For two reasons. One, because why should we have to move resources around to read information about them? And two, in a real world scenario, right? I'm not allowed to touch your NFT, right? And we'll get into that later, right? Because it looks much different than this, obviously. But in a real world scenario, I can't just like withdraw Raven's flunks, right? Like I have to get to them somehow without actually moving them around. So that's where references come into play. They allow us to look at an NFT without moving the location of the resource. So the way that we do that, let's just look at this chapter really quick, is right here, this function. So let's do that right now. So let's say public function borrow NFT, right? Let's say borrow NFT ref for reference. We're gonna pass in a key, is a UN64, and we're gonna return a reference to an NFT type. So this is a new symbol. Yay, we've got to a new symbol. This symbol means reference. So it means it can be a reference to anything. So if we see like, this one means reference to string. This means reference to a resource, which is an NFT type. This is a reference to integer. But I will mention that a reference to integer and reference to string, you'll never ever see that because it doesn't really make any sense. The only time you're ever going to see references are when it's resources. So these two don't really make any sense. So just to mention that. But don't think it like has to be a resource type, but anyway. So yeah. So how do we return a reference to this NFT without actually moving it? Well, let's do that together. Let's return a reference to self.storage at the key, right? Yep, great job, Raven, exactly. So a reference to self.storage at the key. Now, there's a problem, expecting casting expression. So with references, you always, always, always have to put as and then the type you're expecting, like that. So this is saying, I want a reference to self.storage at the specific key, which will give us an NFT type, as a reference to NFT. All right? So boom, let's go ahead and deploy this contract. Yes, we did it. And let's go ahead and deposit an NFT so one actually exists. So let's call it Ricardo. And the NFT ID is going to be 50. All right, so let's put one in there. Hopefully it works. Nice. We deposit an NFT. So now we want to read Ricardo's name. Okay, so let's go to a script. Get rid of all this, and we're gonna take in a key, which is a UN64, and we're gonna return a reference to a hello world.nft. All right, so let's return hello world.borrow NFT ref and pass in the key. So the key, let's say it was, I think I typed in 50, right? Oh my god. Please. 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 I just want to teach my students. No. Well, you guys get the point, right? Like, do I have to sit here and mess with this? Share button? Let's try it. Oh my god. Well, okay, here, one last attempt. Like a new playground. Copy the contract over. Deploy it. All right, nice. Let's deposit. Yay, I love Playground. LOL, it's so fun. Oh my god, I'm having so much fun. Okay, we're getting somewhere. Okay. Script. Okay. Nice, we did it. All right, so anyway, yeah, so here it is. Now here's the reference. So notice, and more simply, by the way, we could just say let reference equals this. And references, by the way, they use equals, so no move. Move is only for resources. Then return ref.name, and that will return a string. So if we type in 50 here, it should return Raven, right? Because it's getting a reference to the NFT type. And remember in Cadence, we can even like help ourselves by putting the type here, right? So it's getting a reference to a hello world NFT, and then returning ref, which is this .name, and we get the string. Boom. And also let's try and put 10. Okay, well, I don't know. Now it's being buggy. So a memory leak. Jacob faster than Playground back and confirm. True. I'm way better than it. Even I know, right? It's crazy. Yeah, crazy. So all right, so that is references, but it's actually kind of funny. So this boot camp, right? This is the May boot camp. Funny enough for you guys, in the middle of June, they're actually completely changing this. So LOL, haha, sorry. They're completely changing this in the middle of June. The reason for that is because since 2020, like literally since 2 years ago up until now, the way that you got references to things in dictionaries is you said reference to self.storage at key and then as reference NFT. Now, like you may not see this at first when you're first learning it, but let me, explain what sort of sucks about this is that right now, if nothing exists here, right? Because remember we said, Bruce, oh my God. Remember we said that when you look at something in a dictionary, it returns an optional, right? So if we typed in a bad key here that didn't exist, right now this would just give us a weird error. It would say like, oh, it doesn't exist, whatever. But if it does exist, it's fine. In the new version of Cadence, so this is around the middle of June, the way it'll work is it'll actually return a reference optional type like that. So of course, Cadence doesn't like this right now because this isn't out yet, but it's going to return this. So yep, this is for secure Cadence. So I actually did a video on this if you want. You can go to my YouTube channel, and this video we did called Secure Cadence. This actually walks through. You'll notice right here that I actually did it I was walking through how to do it right now. Anyway, that's for a different time. But in the new version of Cadence, it's going to return a reference optional type if you're indexing into a dictionary. And then you can unwrap it by putting this whole thing, putting this whole thing in parentheses and then unwrapping it. And that will return a regular reference to the resource. So again, don't worry about this for another month and a half. But yes, a memory leak, exactly. So every contract that's in production right now will have to be upgraded or they will break. Yep. So I guess why not bring it up right now? Because I guess it's helpful for all of you. But again, I would really watch the video I did because it'll help you out a lot. But you'll notice that in this forum post, it says it's coming out on June 15th. But on testnet, it's coming out on June 8th. So you want to make sure that any changes like that in your contract you put them on testnet on June 8th. And then that way, when June 15th comes, you can update your contracts. Because on June 15th is also when permissionless deployment's coming out. So everyone can deploy their own contract. Which, by the way, this bootcamp ends the beginning of June or the end of May. And 15 days later, you'll be able to deploy all your NFT contracts on mainnet, which is pretty cool. So, yeah. Yeah, just like Raven said, when June 15th comes around, pretty much all hell is going to break loose on Flow. Because, like, half the contract's going to be totally broken. True. Yeah, the Flow ecosystem is on fire right now. In a good way, I mean. Like, there's a lot of hype going on. But yeah, so I'm assuming most of you watching this don't have production deployments, but if you do, look out for that. Yeah. So Ricardo says, "Am I going to lose my top shot moments?" No, 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 no. You're not going to. So all your stuff's going to be totally fine. Yeah. A memory leak says, "I hope people skim the transactions they're authorizing." That's a great point. Again, I mean, I'm not trying to self promote, but I guess whatever. I guess I am able to. But on my Twitter, my pinned post right now is a thread about mainnet deployment and how dangerous it is. Because for right now, the way that the way that Flow works right now, if some of you are new, is that right now nobody is allowed to deploy their contract on mainnet unless the Flow team authorizes it. So unless the Flow team says, okay, your contract is good, they will put it on there themselves. You can't do it, which is good, right? Because that means that Flow right now is safe because no contracts are bad. But when June 15th comes around, they're doing something called permissionless deployment, which is after this date, everyone will be able to put their own contracts on mainnet. So you have to be really, really careful about the transactions you're signing because someone could and I'm saying this like I would never do this, but I could easily make a contract that just withdraws all your NFTs and flow token and just give it to myself if I wanted to. Of course, I would never do that, and I hope no one will. But we'd be stupid to say that that's not going to happen because there's always malicious users. So when this happens, June 15th, I'm telling you, be super, super, super careful about what transactions you're signing because with one click of a button, you could lose everything. Yep. So one thing I'll mention, and actually, Q2 Tech, I'm gonna move that question to next week because next week is where we're gonna be talking about the prepare phase, and this deals with account storage. So if you don't understand this yet, it's totally fine. I know we're out of time, but if you're curious, what this means, this auth account type, this is your account storage right here. So every single NFT and all your tokens and literally everything you own is stored in your auth account. So if you ever see a transaction where someone's doing some contract up here, like let's just say contract, I don't know, like random contract, like a random contract. If you ever see a contract where someone's doing random contract dot some method and then passing in your auth account like that, right? Your auth account, that means they're probably gonna steal everything because they're taking your storage and they're putting it into their contract code. That's probably just taking all of it away. I know, it's really scary. And in addition, this can technically be done in transactions too right now because right now, if I just did account, let's just say let all your NFTs and I did account dot withdraw all your NFTs. Again, it's much more complicated than this, but you get it. Then I could just say, my account dot deposit all your NFTs. So wherever you see this account right here, whatever variables right here in the prepare phase, sometimes it's called account, sometimes it's called signer, sometimes it's called authorizer. Whatever you see right here, if you ever see this variable being used in your code or in the code, then it's really bad. Well, I mean, and not always, because sometimes you're signing a transfer function or something like that. But yeah, you sort of get the point. All right, so with that being said, let's just use this as a learning experience. Let's go to float and let me send this float in the chat so you can all claim it. 3 people already claimed it. What? Did you guys guess the password? Oh my god, you must have guessed the password. But anyway, so everyone look at my screen really quick. The code is resources are fun. All right. But everyone, if you want to learn about, account storage, look at my screen really quick while we're doing this. When I click on claim this float, right? Look what's happening. So look, when I do this, I click on script here, right? Look at the code really quick with me. So it's helpful to learn. Look at what's happening. This is the prepare right here, right? And this is the account and this is the auth account. So what's happening is right here. Wait, can I scroll over? Okay, I can. right here, it's saying account.borrow your float collection, right? Oh god, come on. Wow, this UI is terrible. But anyway, it's getting your float collection and depositing to you an NFT using your account. So right here, .claim, and it's passing in your collection right here to claim you an NFT. So when I click approve, it'll do that. Also, I've used that phrase a ton. I think that's why. Resources. All right. So that's the end of that. Yeah, that's the end of that workshop. I hope that was helpful. And yeah, that was resources and references. So thanks everyone for coming. Yeah, that's all I have for today. I'll see you on Friday. I promise you that was one of the more complicated lessons. So if you got lost, it's totally fine. Watch the recording. I'll post it as usual. Thanks everybody, and peace.
Jacob, I have something for you, just really quick if you have time.
Sure. Yeah. Let me stop.